Hello everyone, hope you guys are doing well. On this video I'll be talking about the nomenclature, which is naming. Overall, we're gonna talk about the naming of hydrocarbons. Okay, so let's get started. We got the lesson objective as we have in the other chapters. By the end of this lesson we'll be able to determine the longest chain, number carbon atoms in the longest chain and name it properly, identify functional groups, which is the suffix, and then naming branches with numbers properly, which is going to be helpful for prefix, and then we're going to name the whole molecule by combining prefix, root, and suffix of the compound. So IUPAC is the International Union of Pure and Applied Chemistry, which is the organization that decides on the naming of organic compounds. And they said that we're going to follow this pattern where we have the prefix in the beginning and root in the middle, and then we're going to have a suffix in the end. So we combined all of these three and we're going to end up with the name that we're looking for. I think everybody is familiar with this root. Root indicates the number of carbon atoms in the main chain or ring. So please pay attention, the main chain or the ring, okay? And then the main chain is the longest possible chain and must include multiple bonds. And if there is a ring, it is usually the main chain. Okay, so if we don't have a ring, and then we're gonna go with the chain, but if we have a ring, it's gonna be the main chain, usually. And the names of the roots are these, and the first number, if you have one carbon, number of carbon, if you have one carbon, it's met, second is eth, prop, bot, pent, hex, hept, oct, non, dec. Okay, so number 10 number of carbons is gonna be dec. Okay, now we're gonna go into the suffix. Suffix indicates the class of compound, the class, okay? The class of compound is important according to its functional group. So do you remember we have discussed the alkanes? We have talked about alkenes with the double bond. And then we had alkane, alkene, and then I also showed you the alcohol, which end with ol, alcohol. When you have a carbon attached to OH group, it is alcohol. Okay, and then there are other ones that we have in here: alkyne, alkane, alkene, alkyne, and alcohol. This is the most important four which we will have in our material mostly covered. The other ones are going to be discussed next term. Okay. And then prefix. Prefix indicates the name and location of each branch. So do you remember we talked about having a branch? So we use those to find where the branches are. The functional group on the main chain. So if we have a main chain, for example, this is the line diagram, that was a main chain. And if you have a branches attached to it, these are called your branches, okay? But this guy, the one in the middle, is your long chain, okay? Or you may have, for example, a ring, okay? And then you can have branches attached to it as well. So this is again these are your branches. But your main chain or the ring is going to be, the main chain is here. So this guy is a main, same thing, main, and these ones are the branches. Okay, and over here you need to pay attention. Alkyl group is a hydrocarbon branch with the suffix YL. The suffix of YL, and I'm going to explain you those ones as we go in the next slides. So naming carbons, we need to go according to 4 rules. So we have here, find the root, longest chain, assign the position numbers on the main chain, find the suffix, which is an, in, ein, or ol2 for ethanol, and then find the prefix, which are the branches, and combine prefix, root, and suffix. These are the 4 rules. So there are some other rules that they go into detail. This is a bit of like a short summary, but you have more detailed rules. I'm going to discuss the ones that's a bit different than the one we have seen in the previous slide. So we're going to determine the longest chain. It is the same. Determine which end is nearest to the branch. Okay, to the branch. We always want to find the numbering which would be closest to the branch or a double or triple bond. Number the carbon atoms from end chosen. So once we find which end we're going to start numbering, whether it's from left or from the right, we would know where we start numbering. And then we're going to name each band with the ending YL, like alkyl groups. Then the longest chain, then any single or double bond. When 2 or more branches occur on the same carbon atom, the number of carbon atoms is indicated for each branch. So if you have, for example, you see like this one in here, if I had another branch in here and this carbon is like 1, 2, third carbon, I would still say 3 and 3. I would mention each branch for it separately. So this is the rule number 5 in here. And then when you have 2 or more identical branches occur in different carbon atoms, you would use prefixes D3 tetra. So if you have a methyl group attached many times, let's say 3 times, you would say 3 methyl. Okay, this 3 is going to show you that you have 3 of them. And then avoid the common errors: not identifying longest chain, not listing the side branches in alphabetical answer, and omitting the prefixes D3 tetra. So if you don't find the longest chain, you're gonna write the wrong name anyways. Not listing side branches. If you don't put them in alphabetical order, for example, you have ethyl and you have methyl. So you know that E comes before M, right, in alphabet. So you're gonna write, let's say, 2 ethyl and then 3 methyl. This is how you need to write, because ethyl alphabetically E comes before M. And then, as I told you, if you have 3 of the methyls, you need to say 3 methyl. If you have 2 methyls, you would say 2 methyls, you're gonna say dimethyl. If you have 4, you would say tetramethyl. Okay, naming organic compounds, and there's some addition in here too. There are a set of rules used to name carbon atoms and distinguish between different isomers. Isomers we're gonna discuss in the next chapter. In the systematic naming of straight chain hydrocarbons, the first part of the name refers to the number of carbon atoms in one molecule. The name of hydrocarbons ends with "ane", okay, if carbon-carbon bonds are single bonds. I told you guys, it's alkanes. Alkanes have only single bonds, okay? So if you have carbon-carbon, only single bonds, you would end the name with "ane". If you have one double bond, okay, and then you would say "in". If you have triple bond, you would say "ein". Okay, now let's get into the alkene naming. Name the straight chain alkenes. First, number the carbon atoms in the chain, starting at the end that will give the first carbon atom involved in double bond the smallest number possible. What does that mean? So you see I have here 4 carbons, right? 1, 2, 3, 4. And then I have here 1, 2, 3, 4. But I have a double bond here, right? And then my double bond is in this case. So this means that I wouldn't number this carbons 1, 2, 3, 4, because in that case I need to write the root. Root is but, because I have, if you remember, but was standing for 4 carbons. So but, and then over here I have to write 3 3 in, because my double bond starts on number 3 if I number it from right to left. But because the right numbering happens carbon 1 here, it goes from left to right, it'll be 1, 2, 3, 4. Now I write my root 1 boot, and then I put my number. You see where the double bond starts? I would write first carbon boot, and then I would finish in, which is my suffix. Okay, and then this is my root. Because I don't have any branches in here, I don't have any prefix. Okay, so I don't have any. So I'll write root and then suffix. But look at this guy. If I number it from here, from left to right, it'll be 1, 2, 3, 4. So it's on the second carbon, the double bond starts. And look at if I do it from right to left, 1, 2, 3, 4. It's the same thing. If I do numbering again, it will be on the second carbon again. So my root, if I do the numbering, it'll be boot the root, which is because I have 4 carbons, 1, 2, 3, 4, and then second carbon is where my double bond starts, and then put 2 in. Okay, so this is the right way of doing it. You always want to get the smallest number as possible, but this one here, this one is not right because it gave me boot 3 in. So the numbering of the starting chain starts at this end, and the isomer is named according to the first carbon atom involved in the double bond. So the first carbon atom here is 2, and the first carbon atom here is 1. So if it's not clear at this point, don't worry about it. We're going to do more examples and it's going to become clear. So branched hydrocarbons. Now we're going to talk about the branching. So you remember in the previous slide we discussed root plus suffix, but we didn't discuss any prefix, right? But this time we're going to talk about prefix, which has to do with branches. Okay? The branch, an alkyl group, most often forms a branch in a branched chain hydrocarbon. Okay, alkyl group. So I want you to guys pay attention over here. An alkyl group is an alkene molecule less 1 hydrogen atom and is named after alkene from which it is derived. For example, CH3 is a methyl group. So if you guys remember this CH4 with 1 carbon, it is called methane, right? But if I delete this hydrogen and make this guy just to be connect with anyone, this thing is gonna called met. You see, this is the root. Ending is gonna be with YL. It'll be methyl. Okay. So if you see here, we have one CH3 group attached. I told you guys the rule is to find the longest chain. Longest chain, if you look at it, it is this one. It starts from, and then we start numbering. I would start 1, 2, 3. Okay, because my root has 3 carbons in it, I'm gonna say prop. Okay, and because it's all single bonds here, this is an alkane, right? So my suffix is ane. So it is propane. Now I need to add my prefix. Prefix is gonna go for my branch. So my branch, you see, it is this methyl group, right? Methyl group. Because it is located on the second carbon, I'm gonna say 2-methyl propane. This is the name of this guy. Okay, so you can read this stuff, but I just pretty much did it at practice with you. I identified the longest chain, and then I identified the side group that forms the branching chain, which is side group is this guy, and then number the carbon atoms from one of the ends of the longest carbon chain so that the side group is attached to the carbon atom with the smallest number possible. You see, again, the smallest number possible. Over here, I started numbering from left to right because it would give me the smallest number possible on the second carbon. And the same thing in here. I started numbering from left to right in this way, but for this specific compound it doesn't matter. Even if I would, let's say, number it 1, 2, 3, I would still get 2-methyl propane because my methyl is located on a second carbon, whether I number it from left to right or right to left. But I'm going to show you other examples where you need to watch out for that, because if this 2-methyl propane, if there's another possibility of having 3-methyl, you would always want to go with the 2-methyl propane because you're looking for the smallest number possible. Okay, smallest number possible. So now we're going to review what is methyl again. So I told you this is methane, and then you remove one hydrogen, it becomes methyl. Okay. Now, if you remember, we had also ethane, which is C2H6, and then you remove hydrogen, you remove hydrogen, and it becomes, this is ethane, this was ethane, and this becomes ethyl group once you remove this hydrogen. And then you also have propane, for example, right? 3 carbons. This is propane. If I remove this hydrogen, it becomes propyl. You see how is the ending? YL, and then YL here. It is because it is alkyl group. Now, let's do this one, rules for naming alkanes. Find the longest carbon chain. So if you look at this guy, the longest chain over here is going to be this one. Because you have how many carbons? You got 1, 2, 3, 4, 5. Okay. Now, this gives the parent name of the compound. So it gives us the root. So if you remember, one was met, and then eth, and then at 5 it was pent, right? So this is the pent is your root. Okay. Now we move on. Now we start numbering. If I start numbering from left to right, it will be 1, 2, 3, 4, and 5. You see, my root plus suffix and then plus prefix in the beginning, right? So my root is pent. My suffix is gonna be ane because I only have single bonds everywhere. And my prefix has to do with my branch. And if you look, my branch is located, my methyl branch is here. So if I start numbering from left to right, my branch will be located on carbon 4. But if I do it from right to left, as given in here, 1, 2, 3, 4, 5, it will be located on a second carbon. So because numbering from right to left gives me lowest number, like 2 instead of 4, I'm gonna go with numbering from right to left. Okay, so I'm gonna write here 2-methyl, this is my prefix, plus pentane. So it will be 2-methyl pentane. And ane is because it is alkane, and alkanes are all single bonds. Okay, now rules for naming alkane again. So we did this. Now we're gonna go with this guy. So we have here the longest chain is this, okay? We have 7 carbons here. So which way I should start numbering? From left to right or right to left? If you look at here, if I start from left to right, I have my branches on second and fourth carbon, okay? But if I do it from right to left, it'll be 1, 2, 3, 4, 5, 6, 7. So in this case, it'll be 4, 2, 4, 6. But if I go from left to right, it is 2 and 4. So of course I'm not going to choose this guy because I want the smallest number possible. So my root is 7 carbons, so it'll be hept. And because I have only single bonds, it is ane, heptane. And then my prefix is going to be 2 and 4. You see, I have on a second carbon and fourth carbon, second and fourth carbon, I have methyl. So I'm going to number each one of them. So 2 and 4, and then I'm going to say di because I have 2 methyls. You see, I have 2 of the same branch, and then I'm going to go 2 for dimethyl heptane. This is the name. And then for this guy, again, let's look at the longest chain. I have here the longest chain is this guy because I got here 6 carbons. That is the longest chain possible. But if you look at, there's another alternative, but it gives me a lower number. So I got 1, 2, 3, and then I have here 2 carbons, right? So it'll be 4, 5. It's still less than 6. So I'm going to choose this guy as my main chain. But these ones are going to be my branches. Okay? But I want you to pay attention. So CH4 was methane, and then if you take out 1 hydrogen, it is CH3, right? This is methyl. C2H6 is ethane, and then if you take out 1 hydrogen, it is C2H5, it is ethyl, right? So this guy is ethyl and this guy is methyl. I start numbering again from the point that will give me the lower numbers. So if I'll go from left to right, 1, 2, 3, 4, 5, 6, I got branches on third and fifth, right? 3 and 5. But if I go from right to left, 1, 2, 3, 4, 5, 6, I have it at 2 and 4. If you see, like these numbers are giving me the lowest one, because if you add them up, it gives 6, and this one, guys, give 8. So I'm not going to choose this one, but I will choose this guy. And I'm just going to put my root. So my root is what? Hex, because I have 6 carbons. Hex, and then because I have only single bonds, it'll be hexane because it is alkane. And then so this was my suffix, the ane, and then plus prefix. So I got here ethyl and methyl. As you see here, ethyl starts with E and methyl starts with M. I put ethyl first because alphabetically E comes before M. So I write here 4 because it is located on 4th carbon, 4 ethyl, and then 2 methyl hexane. This is the name of this guy. Okay, so now let's look at this guy. I got here propane because my longest chain is 3 carbons. Whether I go this way or if I go this way, the longest chain is maximum 3 carbons. Okay, so I'm gonna go the longest chain, this one, and then I will start numbering either 1, 2, 3, or I'll go 1, 2, 3. Doesn't matter. It gives me still for methyl group, it'll be on the second carbon. I have two methyl groups, so it will be prop is because I have three carbons. Prop is the root, and then because I have only single bonds, it'll ane. This is my suffix, and then my prefix is gonna be 2 2. Again, because I have the same branch, it'll be dimethyl, so propane. So as it's given in here, 2,2-dimethyl propane. They forgot the L in here. Now this is the draw the condensed structure for formula 2,2,4-dimethyl hexane. Now we're gonna go backwards. Okay, we're gonna go backwards. I just want you to guys pay attention first. You can read the rules too, but the way I would start, I'm just gonna say hex because I have 6 carbons, right? So now it's asking us to do a condensed structure. I'm gonna do condensed. I will also do line as an extra for you. So hex is 6 carbons. So I'm gonna put 6 carbons on the row. Okay, and then it says 2 4. So 2 4, and then I have hex 1 in. So on the first carbon, I have a double bond because you see this is alkene, right? So the first carbon, I have a double bond. I start numbering from left to right, and then I would go 1 2 in the second carbon, and on the 2 3 and 4th carbon I have a methyl group. It will be methyl, okay, like this, and then I'm just gonna fill it out with the hydrogens. So this guy is gonna be CH2 because carbon is gonna have 4 bonds, so 1 2 and then 2 here is 4 bonds. This carbon is not gonna have any more hydrogens, but this one in here will have 2. This one in here will have 1, and then H2 and H3. Remember guys, I fill it with 4 bonds on carbon because I have 4 valences. So if you count each carbon in here, you would see that all of them have 4 bonds. So that's how I fill my hydrogens. Okay, this is the exact same thing I got in here, and I'm gonna do the line structure for you. So I got 6 carbons, right? So 1 2 3 4 5 6, and then I have a double bond here. I have a methyl group here, and I made a mistake. This is not here, but this is here. So 1 1 2 3 4. So 2,4-dimethyl hex 1 in. Okay. So this is how it is. Now we have some practice questions here. I'm just gonna draw you guys the line diagrams for a few of them, and then I'm gonna switch on to the next slides over here. So hex 2 in, you know that it hex is 6 carbons, so 6 carbons in here, and I have a second double bond, so 1 2, so double bond would be here. So this is A, and then I got 2 methyl propene. So prop in, this is same as prop 1 in. Okay, if you have 1, you can also write it propene. This is old school way of writing it. The prop 1 in is like a more modern form. So propene is 3 carbons. Okay, so I put it on the first carbon, and then this is 2 methyl, and then 2 pentyne. So 1 2 3 4 5. And then pentyne, again, it is pent 1 ine. So on the first carbon I have this. Oh, sorry, it's actually telling me it's like 2 pentyne. So this guy means that pent 2 ine, because there is no prefix here. We know that the second one is gonna stand for the second carbon, so pent 2 ine. This is the one we have for C. And then for D is 4th. So I'm just going to write this one and I'm going to move on to the next question. So I got pent to in, so it is alkene. I got 5 carbons, and then on a second carbon I have a double bond, and then on a fourth carbon I have methyl. So 1, 2, 3, and 4. So it is easier to actually draw from the name because you can number the carbon the way you want it. So now, and you can do the rest of them, and if you have questions you can come and we can talk about it. So alkenes general rules. This is a bit of a review. Determine the longest chain. Determine which end is nearest to the branch. I told you guys, we always try to go near to the branch or the double bond. So double bond, or triple bond, they have higher priority than branch. So for example, if you have this guy in here, and then if you have a double bond here and you have a methyl group here, you would start numbering from the double bond, closer to double bonds. Okay, you wouldn't number closer to the branch because you will get the smallest number on branch. Because I told you here, double bond and triple bond has a higher priority than branch, you would number closer to the double bond or a triple bond. Okay, number closer to them, closer to double or triple bond, then branch. But if you have only branches, then start numbering closer to branches. Okay, this is all the rules that we have discussed. Now in here we have the skeleton given to us, so let's do a few of them together. So the longest chain again is this one. You see I have 5 carbons. I start numbering from here, 1, 2, 3, 4, 5. So my root is 5. So it is going to be pent. Because I only have single bonds, it'll be pentane. And then because on a second carbon I have this methyl group, this is going to be 2-methyl pentane. So methyl can be denoted as C or CH3, okay? And this guy is ethyl, I talked about. So I'm going to start numbering 1, 2, 3, 4, 5. I forgot to locate the longest chain. This is the one, the longest chain. And that's why I started numbering from left to right. And this guy is 2-ethyl. 2-ethyl pent because 5 carbons. And then ane because it's a single bonds. Now you can complete this ones. Special cases with branches. Again, this is a review. If you have more than one branch on the same carbon atom, the number of C's indicate for each branch. If you remember, we had carbons where we had carbon methyl in here and then methyl in here. Let's say this was a second carbon, we were saying 2,2-dimethyl, because we had to number each carbon, each branch. When 2 or 3 more identical branches occur on different carbon, you say D3-tetra. So we said that if you have the same identical branch, you would write as many branches as you have. If you have 4, you say tetra. If you have 3, you say 3. If you have 2 of them, you say D. But if you have 1, you don't say anything. You just write the branch name, like 2-methyl. If you have different branches, for example, ethyl-methyl, you indicate the location, name first ethyl and later methyl. The reason is alphabetical order. We have discussed this already. And then I just want to tell you one more note in here. So for example, if you have a pentane, right? And then you have one methyl group and then one ethyl group. So ethyl group in a line structure is like this. You start, I want you guys to ask yourself, where would you start numbering? From left to right or from right to left? You can pause the video. Now I will tell you. So you need to number it from the left to right, not from right to left. The reason is you will always start numbering from the smallest branch. And in here, methyl, this is methyl. CH3 is smaller than C2H5, which is this guy. But when I write the name, I write 4-ethyl and 2-methyl pentane. The reason is because alphabetical order. I need to go, ethyl comes before methyl, but I start numbering closer to methyl because methyl is smallest branch. Okay, so remember this. This is very important. Okay, now practice again. I'm just going to do one of them. So I'm just going to do this guy in here. So I have here the longest chain is going to be this. And then I start numbering from closest to the branch, which will be from left. 1, 2, 3, 4, 5, 6. I got methyl, 2 methyl groups in here. It'll be 2, 3 dimethyl because I have 2 of them. And then it will be hex because my root is 6 carbons, hex, and I only have single bonds. It'll be hexane. Okay. Now I will do a couple of line structures. So this is your branch, right? For example, this is the branch. I start numbering from right to left. I want to get closer to the branch. 4. So my root is going to be but. Because I only have single bonds, it'll be butane. And my second branch, which is methyl, you know that in a line structure, this means the end is carbon, and carbon comes with 3 hydrogens because I need to have 4 valency, right? So 3 of them here and 1 goes to bond with another carbon. So butane, it'll be 2-methyl butane. Okay, and I'm gonna go with the one here on the left. So it doesn't matter whichever way I start numbering, from left to right or right to left, it will be 1, 2, 3, 4, 5. So my branches will always be 2 and 4. So that's why even if I number it from left to right, it will be the same. Okay. So I'm gonna write this guy's name is, because I have 5 carbon, it'll be pent, and because I only have single bonds, it'll be ane. It will be 2,4-dimethyl pentane. Okay, this is the name. And then for this guy, again, the longest chain is again this one, you see, and the longest chain for this guy is this guy. So in both of them I have 1, 2, 3, 4, 5. So even if I number from left to right or right to left, it's going to be the same number for branch. And the branches are in here. This is the methyl and this is methyl. So it will be 3,3-dimethyl. And then because I have 5 carbons, it'll be pent, and it'll be pentane because everything is single bond. And this guy in here, this is ethyl and this is methyl. So I start number closer to the branch. It'll be 1, 2, 3, 4, 5, and the name of this guy will be 4 not 4. It'll be 3-ethyl because ethyl is alphabetically comes before methyl. 3-ethyl, 2-methyl, and then pent because I have a root of 5 carbons, and ane will be because it's alkane. Everything is a single bond. You don't see any double bonds in here. And then alkenes and alkynes. I want you guys to read the rules in here. You add the ending of "-ine" or "-ine". We have done already some of them. And then show which carbon atom first involved in the double or triple bond. So the name with the branches are going to be the same, but I want you to guys pay attention. So you go closer to to double or triple bond. And your first carbon is going to be the carbon where the double bond or triple bond starts. The next carbon gotta be the one that it finishes. Let me show you. So the longest chain on this guy, if you see, this is the one, right? So we found the longest chain which has a double. Determine which end nearest to the double or triple bond. So which one is the nearest to the double bond? This is the end, right? This left end. So I start numbering from here. 1, 2, 3, 4, 5. So because I have 5 carbons, it'll be pent, my root, and it will be 1, the first carbon where the double bond starts, and it will be in because it is alkene, right? I have a double bond. And then because on a third and fourth carbon I have methyl group, it'll be 3, 4, and then will be di, because I have 2 of them, dimethyl pent 1 in. And then for this guy, the longest chain is this. I start numbering closest to the double bond, which would be 1, 2, 3, 4, 5. I wouldn't go from here, okay? This is not where I'm gonna go. I'm gonna go from left to right, because this is where the double bond closer. And then this is ethyl, and this is methyl. So in here I would have the first ethyl comes because alphabetically ethyl E comes before M, so it will be 2 ethyl, 4 methyl, and it will be pent because I have 5 carbons, and it'll be 2 in because second carbon where the double bond starts. And then for this guy I have 4 carbons, longest with the triple bond, and triple bond, you know, it is alkyne, and then I'm gonna start numbering from left to right because that's where the triple bond starts. 1, 2, 3, 4, so it will be 3 methyl because I have methyl group on the third carbon, and then but because my root is 4 carbons, but, and then it will be 1 ine. Okay, so I just want you to guys remember the root was, so root has to do with this, guys. Okay, so if I have 4 carbons, I'm gonna start with but. If I have 5 carbons, I'm gonna start with this is my root. If I have 8 carbons on the root, it will be oct. And if it's all single bonds, it'll be octane. If I have 1 double bond, it'll be oct. And then let's say on the first carbon I have a double bond, oct 1 in. Okay, so now we go back to where we left. So now I'm gonna do the line diagrams for you guys. So longest chain in here, the first one, I have this guy, right? So if you number it, it'll be 1, 2, 3, 4 carbons, right? So root for 4 carbons would be but. And then on a second carbon, I have a double bond, you see? So it'll be 2 in because double bond is alkene, ending is alkene, and triple bond is alkyne. And then this is the name for this guy. I don't have any branches, so this is the final name. So now let's look at this one here. You see how many carbons I have? So I'm gonna start numbering from left to right because this is where it's close to the double bond. So 1, 2, 3, 4, 5, and 6. So 6, root for 6 is gonna be hex, and then it's gonna be on the second carbon where the double bond starts, hex 2 in. Okay, and if you do this one, you would see that this guy is, I got 1, 2, 3, 4, 5 carbon. It will be pent 1 ine. because it is alkyne. I have a triple bond here. And I'm gonna do the last one, which is a bit complicated. So you have here, this is your longest chain, right? So where you have the line starting and where you have a corner, this is where the carbon is located. So the third one is here, fourth one is here, fifth one is here, 6, 7, and 8. So I got 8 carbons, so it'll be oct. And on the third carbon, I have a triple bond. It'll be oct 3 ein. This is the name. So now cycloalkanes. We have discussed some of them in our video, but cycloalkanes is pretty simple. So you got 1, 2, 3 carbons, right? So the root is prop. Because you have only single bonds is ane, and because it's in a cycle, you're gonna just write cyclopropane. If you have 4 carbons, it is but, and then cyclobutane, and then cyclopentane for 5 carbons, and 6 carbons is cyclohexane. Simple as that. And then let's say we have a ring, right? Let's name it. So my longest chain or ring is gonna be my main chain. So this is my main chain. I start numbering carbons again, but I start numbering it in a way that it will give me the smallest number possible. It's the same idea, right? So add them up. 1 plus 2 plus 4 is 7. Try to get lower number than 7. If not, this is your numbering, how it's gonna be. So I got here methyl in here and methyl here. So I start numbering closest to the branch. So I'm gonna start going like this: 1, 2, 3, 4, 5, 6. So it'll be 1,3-dimethyl cyclohexane, because everything is single bond, right? It's cycloalkane. And this one is 1, 2, 3, 4, 5, 6. I wouldn't number it 1, 2, 3, 4, 5, 6, because in this case my branches would be 1, 3, and 4, 3, because I have 3 methyl cyclohexane. You see, in this case I got 1, 3, 4 as a numbers, and if I add them up, 1 plus 3 plus 4, it will be 8, right? And it's more than 7, so I don't want this guy. I want the smallest number. And the last rule for cycloalkanes, this is an important one for your exam, I believe. So in this case, do you remember we covered cycloalkanes, right? But this time I have a cycloalkene. That means I need to have a double bond, or I can have a cyclopentene. Okay, a double bond with here. Now look at here. Number the carbon atoms in a ring so that the double bond is between first and second carbon. Okay? Give lower number to the substituent encountered first. Substituent means branches. Number and list the substituent in alphabetical order. Okay? So I want you to pay attention. So again, I told you, double or triple bonds, they take higher priority than branch. So I got here branch like this, but I still start numbering from first carbon from where the double bond starts, and then I continue where the double bond ends, and the third carbon is where my branch is. So first double bonds and then branch. That's where my priority. So that's why it became cyclopentene. So it's not cyclopent 1 in, it's written here, but I want you to guys know this. Cyclopent 1N is the same thing as cyclopent 1N is same as cyclopentene. it's a convention. So for 1, we say that it's just cyclopentene. Because it double bond started on the first carbon, I said that cyclopent, I'm just gonna erase this stuff. So cyclopentene with the 3 on a third carbon, I have a methyl group. So I didn't put 5-methyl. The way 5-methyl would happen would happen. I start numbering like this: 1, 2, 3, 4, 5, right? I wouldn't do this. I'm just gonna start numbering wherever I have the double bond. So double bond started here, so I started 1 on this guy. And then same thing in here again. So the double bond is here. I start numbering from here. But you see, I didn't go 1, 2, 3. I didn't go this way. I started where the carbon bond, double bond started, and then I continued where it finished. So I put 1, 2, 3, 4, 5, 6. I didn't go 1, 2, 3, 4, 5, 6. Because my double bond, you see this rule, number the carbon atoms in a ring so that the double bond is between first and second carbon. So you see it's here, it's in between first and second carbon. So now it is cyclohexane, the same idea. Hex 1N is going to be cyclohexane. And then it's 4-ethyl because alphabetically ethyl comes first. And then 1-methyl. So this is ethyl and this is methyl. Okay, so 1-methyl. So that's it for nomenclature PowerPoint. I'm going to do one more worksheet and I think that should be good enough. If you have any questions, you can come and ask, guys. Thank you very much.